Alright, number 9. Let's do this. So it tells us that we got n equals 480 times 10 to the power of 9. Now they want us to write this figure here as a number in standard form. Now this does kind of look like in standard form in a way. The only problem is that it does not allow us to have 3 whole digit numbers. We can only have 1 whole digit number with decimals, which is fine. So we have to somehow convert 480 into standard form. So let's do it. To convert any number into standard form, we always take the first digit, so in this case 4, put a point and then copy out any possible non-zero digits like 8, right, times 10 to the power something, and then we just count how many digits are after the first number. So in this case we've got 2 digits, 80, so it'll be power 2. Now for the whole equation here, for n, because we have an additional 10 to the power 9, you'll essentially be adding the powers, because when you multiply two terms with the same bases, you add the powers. So we say therefore n equals 4.8 times 10 to the power of 11, and that's it, all done. Now for b, write n as a product of powers of its prime factors. Show you're working clearly. Okay, so in this case, my usual tip for separate these numbers, and whatever you do not multiply them head on, or you're going to be breaking down really big numbers and it'll take you a while. So my tip, let's do 480 first, yeah, and then do 10 to the power 9 later on. Now let's break it down into prime factors. So my first move would be to realize that there's a 0 at the end, so I can divide it by 10, so it'd be 48 and 10, and then breaking down 48 into 2's, we've got 2 times 24, 24 goes down to 2 times 12, and then 12 becomes 2 times 6, and lastly 6 becomes 2 times 3. And when you've broken everything down to its last legs, you just circle them. So 2, 2, 2, 3, and 2. And as for the 10, we break that as well. It becomes 2 and 5. So that's it. So now we've more or less found the prime factors of 480. Now how about 10 to the power 9? So there's a little trick here. The trick is to really ignore the power, and it's to rewrite 10 to the power 9 as 2 times 5. We're going to write this in terms of powers. So we're going to have 2 to the power 9 times, or ignore that, 5 to the power 9. And that's it. We've more or less broken them down, because we can see that we're going to get 9 sets of 2's and 9 sets of 5's. Now finally, they want us to write n as a product of its powers. So in other words, we need to combine everything together. So this is the part where we just literally count them up. So starting with the 2's, we have 1, 2, 3, 4, 5 on this side, and we got 9 on this side. So collecting them, we're going to have 14 2's. So we have n equals 2 to the power of 14. Now we look at the next digit, which is 3, and we only have a single 3, so times 3. And as for the 5, we got 1 here and 9 here. So altogether we got 10. So 5 to the power of 10. Now for c, we need to find the largest factor of n that is an odd number. Well, we just literally found all the possible prime factors right here. And the only possible odd numbers would be 3 and 5 to the power of anything. Now if you're not sure why that's the case, we can pretty much ignore the 2 to the power of 14, because anything that's times in by an even number is going to be even. When you times two odd numbers, you get an odd number. Okay, that's just a little thing to take note of. So odd times odd gives us odd, but anything times an even will make it even. So we're left with essentially 3 times 5 to the power 10, and that is the highest possible odd number you can make. And that's it, guys. That's this question done. All right, number 10. So the shape shown shaded in the diagram, well, that's a lot of S's, is a region between 2 semicircles. Okay, so we've got 2 semicircles, all right? The diameter of the outer semicircle is 12, so this means the whole thing. By the way, when you have circles, it's always best to try and get radius, yeah? So if the diameter of the outer semicircle is 12, then half of it will give us the radius. So the radius for the big semicircle is 6. Now, the next one's a bit interesting. The shape has a constant thickness of 2 centimeters. Notice it's just this length here. Now, if we think about it, it's going to be 2 centimeters all the way around. So essentially from the center, which would be here, if this whole thing is going to be 6 and this part is 2, that means this gap here must be 4. So we actually have a white semicircle with radius 4. So we're going to keep that in mind, yeah? The white bit will have a radius of 4. Okay, next, calculate the area of the shape. Give your answer as a multiple of pi. Okay, so we basically, the main idea is that we want to firstly find the area of the whole semicircle, assuming there's no white bit, and subtract it from the smallest semicircle. Now the area of a semicircle, so let's say total area, the area of a semicircle is actually the area of a circle, which is pi r squared, and then halved. Okay, so to find the total area, it's going to be the area of the big semicircle, so it'll be pi, and this time r is 6 squared over 2 minus the area of the smaller white region, which is pi 4 squared over 2. And then when you put this in the calculator, thankfully your calculator give us an answer in terms of pi, and it'll give us 10 pi. And that's it. This question is done. Alright guys, number 11 now. So there are 12 boys and 8 girls in a class. The boys and the girls have some coins. Alright. Now the mean number of coins that the boys have is 5.5. Let's keep that in mind, yeah? I'm going to call B for boys, and this little bar means mean. So the mean is 5.5. Now the girls have a total of 18 coins. Notice that they never say the mean here. Work out the mean number of coins that the 20 children, i.e. all the boys and girls, have. Okay, so this is one of those examples of a weighted mean equation. Now there's a nice way to represent this. We usually say this. We say that firstly let's work at the boys. The number of boys times the mean must plus the number of girls times its mean must equal the total number of students times the mean of the total number of students. So this kind of formula, overall explains this entire equation. This is literally the weighted mean equation. So we can think of it as the number of boys plus the number of girls give us the total number of students. If you multiply the means next to them, you're going to get this exact relationship. So now all we have to do really is just plug everything back in. So we've got 12 boys, so it's going to be 12 times 5.5 plus we have 8 girls. Now we don't have the mean, but it's easy to find the mean. If you've got 8 girls in the class and altogether there's 18 coins, the mean is literally going to be 18 over the number of girls. And you can just put that in. Now, I wouldn't bother working out here because you can put it in a calculator. And this will give us the total number of children, which is 20 times this mean. And that's what we're trying to find. We're trying to find this t-bar, yeah? So in your calculator, rearrange, put all of this in, and then divide it by 20. And when you do that, you should get an actual mean of 4.2. And that's it, guys. That's this question done. Okay, number 12. So here are the first 4 terms of a sequence of fractions. Okay, so it looks to me that the numbers on the top half are going up in ones, and the bottom we have odd numbers going up 2 each time. Okay, so the numerators of the fractions form the sequence of whole numbers 1, 2, 3, 4. The denominator, the bottom half, of the fractions form the sequence of odd numbers. Okay, just like we said. Now A, write down an expression in terms of n for the nth term of the sequence of fractions. Okay, so what this actually means that we need to find the nth term for the whole numbers and an nth term for the odd numbers, and then put them on top of each other as a fraction. So to do it simply, for the whole numbers, and I'm going to do this really quick and easy and fast, and that'll be the top half. We ask ourselves firstly, what's it going up in? Well, we know it's going up in ones, and then we ask ourselves secondly, what is the term before 1? Because we need to know what the 0th term is. So if it's going up in ones, the term before 1 must be 0, so it'll be plus 0. Now for the second sequence, we do the same thing. We ask ourselves, what's it going up in? Well, it's going up in 2's, so it'll be 2n. And then the term before 1, before the first term, and you can only get that if you go back by 2, because everything's going up in 2. So if you subtract 2 from 1, you get minus 1. And that's it, guys. This is literally your expression. But simplifying this, of course, 1n plus 0 is just 1n, and 1n is just practically n. So it'll be n over 2n minus 1. And that's it. That's your expression found. Okay, part B. So using algebra, prove that when the square of an odd number is divided by 4, the remainder is 1. If they use the word even number, by the way, an even number is always going to be 2n. Whereas an odd number, and this is just it's a clear definition, yeah, be 2n minus 1. So these are properly defined here, so there is no other ways to write them. Okay. Now to prove this, it says prove that when the square of an odd number is divided by 4, so we need to take an odd number, do the square of it, and then divide it by 4, we get a remainder of 1. So alright, let's try this out. So all you want to do is literally expand this term. So 2n minus 1 is literally 2n minus 1 times 2n minus 1 over 4. Now multiplying out the bracket using FOIL, in other words, you do 2n times 2n, 2n times 1, and so on. You're going to get 4n squared minus 2n. Then you got minus 1 times 2n and minus 1 times minus 1. That gives us another minus 2n plus 1. all over 4. So we're going to have 4n squared minus 4n plus 1 over 4. So we're going to have 4n squared over 4 minus 4n over 4 plus 1 over 4. Now what happens here? So when you divide this by 4, these two cancel out, so 4's cancel out and 4's cancel out. So we're left with n squared minus n plus a quarter. Now, what does this actually tell us? Well, this tells us clearly that firstly, you get a whole number here when you divide it by something, and you're left with a remainder of 1 when you divide by 4. And that's it. So really, all they really wanted to see is that you get a quarter, because 1 over 4 is a remainder of 1. Okay, this is the same definition. Okay, number 13. So a curve C has equation given as follows. Find dy of dx. Okay, so this means differentiate the equation. And differentiating is so easy, by the way, guys. This is what you get. So to differentiate, all you do is look at the power and drop it on the ground. So x to the power 3 becomes 3x, and then you subtract the power by 1. So 3 take away 1 is 2. For the second term, you drop the power 2 in front, so you get 2x. Subtract 2 by 1 and you get 1. So just 2x to the power of 1, which you can leave like 2x. Next one is 8x. Now, if you imagine for 8x, you got a power of 1 here, yeah? If you drop the 1 down, it'll be 1 times 8, which is 8. And then you're left with 0. Now, anything to the power of 0 is actually 1. And then you basically got 8 times 1, which is 8. Or a nice way to memorize it is that if you're left with the term x, it always vanishes when you differentiate. And now last bit, when you differentiate a constant, because there's no x attached, it's going to be 0. That vanishes. So you're left with basically this equation here. Okay, part B. So the curve C has 2 turning points, and the curve C is this one here. Work out the x coordinates of the 2 turning points. Okay, so a turning point is literally when the graph turns. As simple as that. Because we've got a cubic graph, and it's cubed because the highest power is 3, it looks a bit like this. So the graph looks a bit like that, something like that. We don't know how exactly, but like that. And we know it turns at 2 points. Some point here and some point here. Now, one interesting thing about this and how it links to dy dx is that when you have a turning point, this means that at this point exactly, we can see that the gradient is actually flat, is 0. And dy dx is literally the gradient expression. So we say, all right, at these 2 points, we must have a dy over dx equal to 0, a flat gradient. So all that essentially means is that you equate your dy dx equation over here to 0 and solve it like you would for a normal quadratic equation. And that's it, guys. That's literally all you do. So solving this quadratic equation, I mean, we just use the standard quadratic formula. So let me change the color pen. We're going to have x equals, so minus b, so b, actually let me write the whole thing, minus b plus minus the square root of b squared minus 4ac over 2a. And therefore x is going to equal, so minus b, so b is negative 2, so it'll be plus 2 plus minus the square root of b squared, which is minus 2 squared, which is 4, minus 4 times a, which is 3, times minus 8, which is c, over 2 times a, so 2 times 3. That's it, guys. And when you put this into your calculator, or if you use a calculator that can solve quadratics, you should get 2 solutions. One of them being x equals 2, and the other one being x equals minus 4 over 3. And that's really it. These are your 2 x coordinates. So we can say that one of the turning points was here, which is probably x equals 2, and this one here, which is probably x equals minus 4 over 3. If this was the graph, the xy axis. Anyway, let's do part C. Show that the x-axis is a tangent to curve C. Okay, what it's trying to say here is that if you plot this on a graph, let's just visualize for a second. It could be one of 2 scenarios. We have a turning point which occurs somewhere and it probably bounces at some line. Let's say it bounced here. Or it could have been like this. One of the x coordinates probably bounced here and then went up. Now, a tangent is when you hit something at exactly one point. In other words, we're treating the x-axis as the tangent itself. So we're going to test whether one of these x coordinates will give you a y coordinate 0. So yeah, sorry, quick recap. When you get to prove something is a tangent to the x-axis, we need to show that it bounces on the x-axis. And if it touches the x-axis, that automatically means that the y coordinate is 0 because it's on the x-axis. It's right over here. Or right over here, which is also y equals 0. Anyway, let's plug in both of these coordinates, yeah? we're going to plug into the curve of y, which is over here. So we're going to say, all right, at x equals 2, if you plug it in, it will be, for example, 2 cubed minus 2 squared minus 8 times 2 plus 12. And if you did that, you'll get y equals 0. And yeah, actually, this is this is your solution. If you get 0 as a y coordinate, it means that you're on the x-axis. However, if you plugged in the other x value, which was what? Minus 4 over 3. If you plug this into this equation, you'll actually end up with a result of something like 500 over 27. Nope. And this is clearly not on the x-axis because it's all the way above somewhere. And that's it, guys. That's literally all they want. So your solution would actually be when x equals 2, y is 0. So that is the x coordinate they want. X equals 2, y equals 0. Now, and that's really it. All right, number 14. So a cumulative frequency diagram gives information about the values in thousands of euros of 120 apartments in 2015. Okay, so this means that, for instance, as the value of the apartment goes up, then we're accumulating the number of apartments. So this means if you're counting every single apartment, all 120 of them, they add up to 100,000 euros. Okay, so A, find an estimate for the number of these apartments with a value of 80,000 euros or less in 2015. So we just put our mouse on 80, scroll up, and it hits somewhere around there. So I'm just going to zoom in a bit, guys, yeah? So, I don't know. Like, what do you guys think this is? It's about over here, isn't it? I think that's about, and it looks like it's going up in 2. So it'll be 92, 4, 6. So I'll say about 96. Would you say 96? Yeah, 96. All right, next one. So the table gives information about the values in thousands of euros of the same 120 apartments in 2018. So it's literally different, comparing ones from 2015 now to 2018. Okay. So according to this data, it says, for example, let's look at the second one. It says up to 40,000 euros, there are 15 apartments that cost that price. Whereas up to 120,000 euros, there's exactly 120 apartments. So it goes up a lot now. Now on the grid opposite, so I mean opposites, I mean where? Alright, so it's probably before it. On the grid opposite, draw a cumulative frequency diagram for this information. Alright, this is very easy. You just treat this like coordinates, yeah? So remember, if you recall, the cumulative frequency is going upwards, so it's on the y-axis. So these are literally coordinates, and this would be the x-axis. So for instance, for each point, we can say up to 20, which is the x-coordinate, we have a cumulative frequency of 0. Next one would be 40 to 15. And it'll be all the way to up to 120 and 120. So that's quite straightforward. So let's do a few of them, and then I'm going to quickly time skip most of them. So let's look at 20 to 0. So it starts from here at the same place. Next one would be 40, 15. So 40, 15. So again, that's 10. So actually, it's the same place. 60 to 44. 60, 44. So actually, 44 is around here. Okay, now it changes up. That's it, guys. That's literally all of them. So now all you want to do is literally make a smooth curve if you can, which I definitely can't. So it's the same here, but then all of a sudden it deviates up to here. And then it goes up more. So yeah, it's kind of hard to draw curves sometimes, I admit. So whatever you do though, do not use a ruler. Okay? Anyway, it looks a bit like that. You know, I'm not gonna lie, it's not perfect, but it does the job. Now, part C. Find an estimate for the increase in the median value of these apartments from 2015 to 2018. That's an interesting question. So literally just find the median for both of them and see the difference. So we can say, all right, the median is literally the middle person. So if you've got 120 apartments, the midpoint would be the 60th apartment. So you're half the value. So we can say at 60, at 2015, the value was somewhere over here. And in 18, or the year before, it's over here. So where's the difference here? So this value represents, let me see, this block over here between these numbers, yeah? So you got 50 here, 52, 54, so about 55, I'd say. And over here, which I'm probably wrong, it's around this value here. So it's just before 70, about 70, 69, about 68, 69, yeah? I don't even know. Somewhere between these two. So the change would be the difference between these values. So it'll just be for, I'm just going to use the value 68 here. So it'll be a difference between 60 and 55, which is going to be 13. So that would be the answer. So this answer at the bottom is 13,000 euro increase.